Welcome to solverfy.
For this question, they are asking us to find the volume in liters of radon produced by 1 gram of radium per day. So to do this, they tell us that 1.0 times 10 to the 15th atoms of radium, abbreviated Ra, produces 1.373 times 10 to the 4th atoms of radon, Rn, per second. So for this question, we're looking for the volume of radon, and we want that in liters. And it says that the conditions for this reaction are at standard temperature and pressure. And they gave us the volume of radium, which is equal to 1.0 grams. And we also know that the molar mass, we'll abbreviate that RAMM, is equal to 226 grams per mole. And we're also going to be using Avogadro's number, so I'm just going to abbreviate that with a big letter A. And that's equal to 6.023 times 10 to the 23rd. Alright, so to first start this question, we need to figure out the atoms that we have of radium. So, Ra atoms. So to do this, we're going to take Avogadro's number, and we're going to times that by our amount of radium that we do have, so 1.0 grams. And we're going to divide this by the molar mass, so 226 grams per mole. And this will give us the atoms of radium that we have. So when we calculate this out, it's going to be 2.67 times 10 to the 21st atoms of radium that we have. Alright, so now that we have the atoms of radium, let's get our atoms of radium, or radon. So we have 2.67 times 10 to the 21st atoms of radium. And this is going to equal 1.373 times 10 to the 4th atoms, because that's how much are produced from the radium. And we're going to times this Alright, and then this is the atoms of radium, because that is how many atoms of radon are produced from that many atoms of radium. I'm going to divide this by 1 times 10 to the 15 atoms of radium. So our atoms of radon is equal to 3.67 times 10 to the 10 atoms of radon per second. Alright, so we do want the amount of liters in a day, so we're going to calculate that out. 1 day is equal to 24 hours, and we're going to times that by 60 minutes because there's 60 minutes in every hour, and then we're also going to times that by 60 again because there's 60 seconds in every minute. So when we calculate this out, it's going to be 86,400 seconds. So we know that 1.0 grams of radium produces 3.67 times 10 to the 10 atoms of radon, per second. Alright, so now we want the amount of 0.1 grams of radium for every day. So that's just going to be 3.67 times 10 to the 10 Rn atoms. And we're going to times that by, that's 86,400 seconds. And this is going to equal 3.17 times 10 to the 15th Rn atoms per day. And then at standard temperature and pressure, we know that the volume of 1 mole of atoms of any substance, the volume is going to be equal to 22.4 liters. That's based on Avogadro's hypothesis. So to get the volume of our radon, we're going to take 22.4 liters. We're going to times that by our number of radon atoms, so 3.17 times 10 to the 15 Rn atoms per day. And we're going to divide that by Avogadro's number again, so that way we just have the amount of liters. So we're going to divide that by 6.023 times 10 to the 23rd atoms. So when we calculate this out, the volume of radon per day is going to equal 1.18 times 10 to the negative 7 liters. And that is the volume of radon that's produced by 1 gram of radium per day.